everyone. American Center Tashkent is happy to welcome everyone at our weekly virtual chat-up. My name is Gulshan, and as you know, October is the Cybersecurity Awareness Month, and you probably noticed a number of posts on ACT social media made with the purpose of helping everyone adopt more secure practices online. And also, to celebrate the Cybersecurity Awareness Month, we have a special speaker today, a senior technology advisor at the U.S. Department of State of Cyber Issues, Len Hause. Hi, Len.
Good morning or good evening, and from Austin, Texas here is morning. So I've had my morning coffee and hope to be able to keep up with you all today.
Good morning to you. And this is a great honor to have you, and thank you for taking the time to do this presentation today.
Well, it's my pleasure. I've always wanted to get to that region of the world. I've traveled many miles with my over my career, and have never made it to Uzbekistan. So this will be my first introduction to the country, and hopefully I'll make some connections for a future visit. And I'll be happy to take the questions today. So. And I have I'm going to frame my presentation a little bit as an intro, because the internet is a big place, and sometimes it's hard to kind of, get an entry point on discussion, but hopefully I'll frame something that'll be of interest to everyone, and look forward to the question. Wonderful.
Thanks so much. And I want to say a couple of words about you so that everyone knows who you are and a little bit about you. So Len is from Texas, and he holds a U.S. patents in telecom and BS degree in electrical engineering from Lehigh University. Previously, he served as a science and diplomacy fellow at the Institute of Electrical and Electronics Engineers. And in 2008, he founded MeshBrain, a consulting company, to assist clients with transformational strategies that leverage internet technology and marketing. And we're gonna hear today, Len, from you about internet, right?
Yes, I'm going to try to compress 50 years all into 20 minutes here. So hang on.
It sounds very promising.
Yeah, right, what I want to do, you can find history, lots of you, you could Google for history of the internet, but what I'd like to frame today's conversation is a little bit on, how we got to this point in the context of the scale and the innovation that happens on the internet, and how it has decade by decade evolved. And then and that will set us up for a little bit of discussion of where it goes from here, and then put it into the context of some of the security issues and concerns that we're going to be facing both now and in the near future. And hopefully the folks will have some great questions for me, and because hopefully I won't answer everything with my presentation.
Yeah, so I want to remind everyone, please do remember that we want to do this as interactive as possible. So if you have questions, put them in the comment section below this video here on Facebook and on YouTube. And we'll have Len answer these questions at the end after his presentation. So Len, I'm giving the floor to you.
Okay.
And I'll see you after the presentation.
All right, great. Mm-hmm. So, okay, we're going to, I'm going to give a little start again. Like I was mentioning, I'm going to just run down through the history of the internet, and I'm going to go through this pretty quickly. But what I'd like to highlight here is how the internet, the internet's not new in the context of networks. We've had networks, and we've had applications on networks for a long time. And but there's some particularly interesting things about the internet that has allowed it to grow and expand it from not only a technology point of view, but from how it's been adopted over the years to become a very important part of our lives. and then take a look at moving forward. So I'm going to start at the beginning. So in 1969, I was in high school, and I was a huge space program nut. I followed all the programs, and a big event for me. I mean, one of my really memorable events was the moon landing in July of 1969. Interestingly enough, that same year, and I was not as cognizant of this development, but in October of that year, the first message was passed on a packet processor, and as part of an experiment of how packets could replace circuits for our communication network. Now, just as a quick point, this was a pretty big deal because what they had an ARPA program, an Advanced Research Project, that was funded by the United States government, in how we could connect computers together in 1969. And at the time, of course, our telephone network was the big network, and that network was based on what we call circuits. In other words, what we need in order to make a connection from one person to another to make a phone call, you had to establish a circuit and dedicate some resources to that circuit for the entire length of the conversation of the connection. And you tied up resources during that, whether you talked or not, you were still tying up a circuit. That was a pretty inefficient use of resources, but it was all the technology would support at the time. So this concept of a packet came along. In other words, to take that conversation or to take that text, and as it was being generated, you put it inside of packets and you ship that packet along a circuit, but it could be along with packets from many other circuits or many other processes, and they would be sent out and reconstructed at the other end to either text or voice. And so this first message came across in October of 1969, and it was a pretty big deal. Now, the computers at the time, it takes a lot of computer power to process all these packets, and the computers at the time are obviously relatively primitive. So so it took a while to kind of get up to the point where it could keep up with the amount of traffic, but that was a pretty big milestone. Then so during the 1970s and 80s, we started seeing developments in the network. Now, again, what I want to remind folks is that there were computer networks in the developed in the 70s and 80s, and a lot of these were fairly sophisticated computer networks. I mean, there was a lot of companies that had their own proprietary protocols. The problem is none of them talk to one another. So if you had a IBM system and then you had a digital equipment system, it was very difficult to get the two of them to communicate. So so an architecture started to evolve of how you would build a computer network and a set of applications that would allow anybody's computer to talk to anybody else's computer. And so we started to see the development of standards around these packets and how they got transmitted. And so we started to see all these individual networks or technologies move to a common standard. And so, which at that point in time during the 1980s, the whole concept of TCP/IP came, and I'm sure you guys can all look that all up. But the important part of this foil is that all these other networks, non-interoperable networks, started to converge to a higher value network, one that was interoperable. And then so once we had networks connected and packets, then it came up to, so we have these other applications, and one of the first ones was mail. Email existed well before the internet email. I mean, we had, again, a lot of individual companies, technologies. We had IBM and AOL and Yahoo, and there was just a whole list of them. All of these mail systems, and some of them could talk to one another, some of them couldn't. It was often done pretty, it wasn't very clean. And if you had attachments or if you had any kind of addressing issues, that was pretty hard to resolve. So again, in the 90s, we saw this late 80s, early 90s, we started to see, again, a set of standards that were developed as part of the architecture that allowed mail to be interchanged between a whole diverse set of architectures and equipment over this standard set of protocols on top of TCP/IP. And then a big change came in the mid 90s in that Tim Berners-Lee came along and with this concept of the World Wide Web, and along with it there was a concept called a web browser. These are two separate concepts, but they came together in the 90s, and we started to see this explosion of content, because not only now could we exchange messages, but we could exchange information and be able to have one computer display information from another computer in a way that people could understand. Obviously, it exploded in terms of the volume, and that went from like the first websites in the early 90s now to, I think, last year, and it's hard to count, but we're up to well over 1.7 billion websites out there. So it was this huge expansion of the internet based on the web protocols. In fact, some people automatically think of the web when they think of the internet, for a long time. And then, so then once we started to have applications, once we started to walk around with phones, and I worked for Motorola for 30 years, so I've been around since 0G. I talk about it now that we're up to 5G. So we started to have applications be the thing that we would go after on our devices, and sometimes it was computers, sometimes it was mobile devices. So the mid 2000s, up until now, we've been focusing in on apps and how apps can manage all the information and access, and again, but it sits on top of, remember, all those protocols and standards that were developed. So I think that's the important message here, is that this architecture that was developed for the internet has evolved and has been able to manage the growth not only of the content and the number of people coming in, but also the technology. So these standards are important. I think one of the important messages of this is not only has there been an architecture, and we always call it the stack, if you will, and it's off to the left of this thing. And so we're seeing, the physical layer of the stack, which is stuff like, your Ethernet and your cell phone radios and Wi-Fi, and a link layer, which allows the physical media to connect data to the network. And these are all standards that were developed as part of what we call multi-stakeholder process. In other words, folks can contribute from private sector, they can contribute from the academia, they can contribute from a variety of folks that can make comments and make improvements to these standards over the years. And they're all open, and you can take those standards and adopt them to your own particular technology from a hardware standpoint, but it's interoperable, and it evolves. And then you have groups like the Bluetooth folks, and the 3GPP for cell phone, the Wi-Fi Alliance for your Wi-Fi, and there's the IEEE, the Institute of Electrical and Electronic Engineers, which does a lot of the standards development around the physical layer stuff. Then up at the TCP/IP layer, you have an organization called the Internet Engineering Task Force, which takes care of this transport and internet layers, which develop the standards. And there's many standards out there, and all of these groups have websites. You can go look at them. And then as you get up into the application layers, you get up into things like the web browser layer. There's the World Wide Web Consortium. And again, these are just a few of the standards areas, but I think these are key if you want to kind of go out and look at their websites and learn about them, for that look at how the websites interoperate with one another, like the HTML and the way that HTTP is secured. When you look up a URL, that it has a security arrangement with it. And they're getting now into things like how you can trust trust websites and make sure that you're not being monitored over your internet connection. So these are important developments, and I bring them up. And again, I just want to bring them up in the context of how the internet got here over 50 years and was able to continue to be interoperable and open and secure and continue to evolve and expand. So now where we're at now, it's like, well, I think we can consider the internet a pretty big success in the context of, well, we've connected half the planet. So that being said, there's the other half of the planet to connect. So we've got, somewhat over 4 billion people on the internet right now, but we've got another 4 billion to go, more or less. So, I mean, even with this amazing growth rate that we've seen, we've got a lot more to go. So when you consider the scale of what we're looking at, and some of you might be pretty sophisticated internet users, but and so, I don't know what the age group here, but whatever age group you're in, guess what? There's a lot more internet growth to go, and I think you all can play. And there's an important role for everybody to play in this. And I want to get into that in a minute here. And I want to give the idea of scale. And so in 1948, the transistor was invented. Well, when I was growing up, I had a piece of portable equipment that played my music, and I held in my pocket. It was battery powered. It was on the left here, and it was a transistor radio. And you can see it's a transistor radio because at the top, if you can see the graphic, it says 6 transistor. And there were some radios had 8 transistors and some had 4 transistors, but there was pretty prominently displayed of how many transistors it had. Now, what I carry around with me now in 2020 is an iPhone, and that is also battery powered, and it plays my music, and I have it in my pocket. It has well over 100 billion transistors in it, and nowhere in the labeling or the packaging is the word transistorized. So somewhere in the line in the way between 6 transistors and 100 billion transistors, we dropped the word transistor. And the reason I mention on that is that we're almost in that place in the internet as we start looking at of how we are calling things that we connect to the internet, whether they're smart devices or they're internet connected devices. And we're kind of at that 6 transistor stage right now. And we started connecting things to the internet. Actually, they fairly early idea back in 1982. There was some folks who at Carnegie Mellon University that hooked up their Coke machine to the internet, and it was able to tell them how the stock of the Coke machine, so they didn't have to go down and find out that there was no Cokes in the Coke machine, so they could find it out from their dorm room. And then, maybe the most famous early internet device was the internet toaster, which became a meme back in 1990. It was the first device that you could actually control over the internet. You still had to put the bread in the toaster, but it could turn the toaster on and toast the bread and things like that. So these were early on, but it kind of took a while before the standards evolved to where we could start hooking up more things to the internet. And so now we're like, okay, we're now here in 2020, and I'm sure quite a few of you have a number of internet devices, and maybe you should go out and count them right now. So when I go out and give talks, for many years now, I've been asking how many internet devices do people have, and they always undercount. But here's kind of some examples. I mean, there are obvious ones like the phones and the laptops and the iPads and the routers and the game consoles. But some of the less maybe known ones are your thermostats and your smart meters, and in some cases people have light bulbs, and your watches and your Fitbits and your smart speakers and your smart TVs. And notice I'm saying smart, and kind of that's another way of saying they're internet connected. So, but I've got roughly 70 devices connected to the internet right now, and and that's going up pretty quickly. And my son now is having a house built, and the house is basically going to be a smart house. So almost everything in the house will be connected to the internet, the fans and the hot water heater and everything. So count the number of devices you have now, think about it a little bit, and then think about how many will you have 5 years from now. And my guess is it's going to be a lot. So not only are we adding 4 billion more people, hopefully, to the internet, but each one of those folks is going to bring a number of devices with them, and that number of devices is increasing, which is going to result in exponential number of new devices on the internet. And that has key interests along with security. And so along with that question of how many devices you have you thought about how secure they are? And not only how secure they are now, but if you're going to still have them, your thermostat or your light bulbs or any other devices you have in your house, how secure are they going to be 5 years from now? And how are you keeping track of that? So these are, I think, questions that we have as netizens who contribute to the whole security of the internet. And I think that's one of the things I think that we're trying to embrace as part of our messaging, as we mentioned with Cybersecurity Month. Another aspect of these devices is that, these devices are generating data, 24/7, 24 hours a day, 7 days a week. And we're starting to see this inflection point where there's more data coming, being shipped up from, the individuals and the houses than there is coming the other direction. I mean, so, and I think the current crisis with the pandemic is showing that as people getting online and they're doing Zoom sessions and they're generating a lot more content and shipping it up, we're changing the data paradigm on the internet from one where most of the data is coming down in terms of streaming movies and things like that, to where there's a lot more data going in the other direction. And what that is going to do is create a new way of looking how data is being stored and processed on the internet. And instead of these big servers, pumping it down, there's going to be data that needs to be processed closer to the data source for either real-time purposes. So for instance, we have a Pecan Street project in the United States where every house and every circuit breaker in a house is connected to a network that monitors the amount of power that's being used on that circuit breaker. And they're literally getting 10 million records per day per house. And those records obviously have a lot of data in them. So they have literally petabytes of data coming from this neighborhood in Austin. And think about your security camera. If you've got a security camera and if it's turned on high resolution, that could produce 100 gigabytes of data per month. And then if you start talking in autonomous vehicles and all the information they have to process in order to move along the road, there's been measurements made of some of the autonomous vehicles where they can transfer 5 terabytes of data per hour while they're in autonomous mode. And that's going to require a lot more networks, a lot more local data processing, because you can't wait for that autonomous vehicle to get an answer from a data center, 1,000 miles away to decide what it needs to do in a traffic situation. So these are all going to be new challenges for the architecture of the internet. And I have confidence that there'll be challenges that will be met. But I think it's going to result in new paradigms that we're going to need to look at. And as it was mentioned, this month is Cybersecurity Awareness Month. And one of the messages we have out there is that if you connect it, protect it. So a lot of this is being aware of the things that you connect onto the internet, and maybe you give some extra thought about the security of these devices and how not only how it is when you connect it, how you get it secure, but how do you keep it secure over the life cycle of that device. And so these are important questions that I think we have to be smarter consumers and netizens as we look at this. And not only that, but what happens when you throw it away? I mean, what happens when you move to another house? How does your data and how do your credentials get protected in that transition life cycle? So these are a couple of websites that you can look at that have some great information that might help you out in those decision processes. And I'm going to keep this is the end of my presentation. I want to get into the Q&A, but one of my favorite sayings is from Tim Berners-Lee, who was the inventor of hypertext and the World Wide Web. And it is true, as far as we've come, and some people think of themselves as, we're pretty far along on this internet journey. We're just beginning, and we've got a long way to go. So my favorite quote is here: the future is still so much bigger than the past. And so I hope this has been a little bit of thought-provoking, and I hope maybe some questions pop up. So I'm going to stop here and stop, my presentation part, and hopefully get into the Q&A, and I'm ready for that.
Mm-hmm. Thank you very much, Len. That was very interesting. We've got a couple of questions from our audience, and before we get to questions, I just want to remind everyone, don't miss your chance to ask your question. This is a great time to talk to an expert.
So of all the things I have connected to the internet, my daughter has given me a water bottle now that is connected to the internet. And really, when you're saying it keeps track of how much, because she's very concerned about her father getting enough liquid to drink. So this monitors how much water I drink in a day. If I don't drink for a while, it sends a reminder to my watch that I haven't had consumed any water. So again, I think you can pretty much assume that over the next 5 years, that if there's any power to a device, that it's going to have the opportunity to connect to the internet. So just to get an idea where all this stuff is headed.
Yeah, this is amazing. You said you have 17 items connected to internet right now, right?
There's all kinds of, there's a lot of, security devices, and I'm a music guy, so I have a lot of smart speaker and musical stuff connected to the internet, and of course, watches and water bottles and thermostats, and I have 4 robots and that are connected to the internet, and so it adds up.
It's like I'm talking to someone from future. All right, we have a question from Abdurrahman Valijanov. He's asking, how many satellites are there in the space, in the world?
Well, I'm not a space guy, but I did work on a project in my Motorola days. I was very ancillary to the project called Iridium, and that was a project that was supposed to launch. It was some 80-some satellites to put in low Earth orbit, and this was during the 1990s to provide worldwide connections to, at that time, the cellular, allow you to have cellular phone calls from anywhere on the planet. Now, that was in the 80s or 90s, and now we have projects going. There's several projects, Elon Musk with of Tesla fame, and Amazon, Jeff Bezos in particular. There's 2 projects where they're literally launching thousands of satellites, and they're launching them as we speak, I think, into the sky in low Earth orbit. So low Earth orbit is a way of, if you have there's several kinds of satellites. One is what would be our GPS satellites, or geopositioning satellites, which are very high up in space, because they have to be in synchronous orbit in order to operate those satellites. But the problem is that at that altitude, the time it takes to get a signal up and back is way too long to be effective as a internet connection. And plus, it takes a lot of power to ship data up to that. So there's another orbital satellite range called low Earth orbit, or mid Earth orbit, which is much closer to the planet, and has been demonstrated recently, the latency, in other words, the amount of time it takes to get a signal to the satellite and back to Earth, is now in a range which is considered acceptable for broadband connections. So the whole idea is, with all these satellites, you will be able to connect and have a pretty reasonably fast connection. Now, they're early in the context of how they're rolling this out in a commercial context. But so the answer to that question is there are hundreds, if not thousands now, but there are thousands more to go. So space is going to be a very crowded place satellite-wise, and that's going to be a challenge, not just from the standpoint of logistics, but there's a security challenge associated with that. Not just the physical challenge of keeping these satellites from running into one another and colliding with space debris and things like that, but also the context of how you secure the signals going up, not to just only control the satellite, but to communicate with the satellites from an internet connection standpoint. So it's a great question, and the answer is there are a lot, and there are thousands more to go.
Thank you. Question from Abdurrahman Walijanov. How can we improve the quality of the internet in Uzbekistan? What are your recommendations in terms of this?
Well, actually, unfortunately, I'm not that cognizant, or I don't really understand right now what Uzbekistan is experiencing in terms of internet connection. From what I've been able to gather, is Uzbekistan has a fairly large percentage of its population that has the ability to access the internet, which is great. And we have even this challenge in the United States. I mean, in the United States, people think of that, we've got all this great technology and we're kind of the hub of the internet. And but I have experience living in Texas, where there are very rural parts of Texas and a lot of the state where it is actually pretty difficult to get an internet connection because there's not enough cellular towers and there's not enough broadband. But to answer your question, Uzbekistan, I think there's a lot of ways to improve that. I mean, there's everything from laying more fiber, which is optical fiber connections are the best way because they're high performance. They can be relatively cheaply installed. They don't require a lot of copper installation, which the previous telephone network involved copper. So that's one way. The other way is to improve the wireless connection, and that can be done either through like cellular connections. The typical, I would imagine most of the connections in Uzbekistan are like 4G LTE, and 5G is probably coming online. That might take a while because we're seeing new architectures coming up in 5G that allow them to be more the cheaper and more interoperable. So we'll see a lot of evolution in that technology as well. But there's multiple ways. I think that the best way to improve the quality is as citizens of Uzbekistan is demand better quality, not just as consumers, but to influence the government to say it's important. I think more and more. I think it's governments and organizations within countries are recognizing that internet connections are not just a way of getting listening to music and watching movies, but it's how we educate people. It's how we make our grids more reliable, electrical grids more reliable. It's a way of improving our healthcare. So these are in our lives of being digitally transformed. A solid, high performance internet connection. Now, since the COVID crisis pandemic has come along, it's been amazing, and I think probably a lot of the people here online will have the same experience of in order to do all your Zoom sessions and your WebEx and all your chat sessions, they've had to upgrade their Wi-Fi to be either mesh or have more reliable Wi-Fi so that they're not cut off. So, I mean, we're starting to see that now during this pandemic, which, I think will benefit, the whole system in terms of how the quality gets improved, because these services and these customers are going to demand higher quality. So there's a lot of technology solutions, and there's plenty of technology solutions. I think it's just a matter now of how governments and how citizens, organize to make everything work better.
Thank you. Next question is from Farukh Hakimov. Thanks a lot for your presentation. My question, how the smart devices secure than they are offline? How secure they are?
Yeah, that is a great question, and there's really no singular answer to that. I think we're starting to see, the original devices. A lot of some of the earlier devices that were called smart devices were really almost relatively no thought to security at all. In fact, a lot of them had default passwords. Some of them that you couldn't even change. I mean, you put them online, and every device that was made by that manufacturer, you could look up the administrative password, and you could break into that device, and there was really no thought. We're starting to see some standards starting to evolve. There's an organization in the United States we call NIST, which is the National Institute for Standards and Technology. It's part of the United States Department of Commerce, and they are coming out with frameworks and guidelines for smart devices that allow consumers to see that there's some standards and practices involved that make sure that things like there aren't default passwords, that there's the opportunity for multi-factor authentication. There's ways of updating the device with new firmware to make sure that it's got any problems that were discovered in the device's software to be updated and improved. So these are all things that are evolving, and they will continue to evolve. And that was one of my questions. It's like you have to, when you're being a smart shopper for these devices, you want to go out and have those questions or do that research up front. So when these, and sometimes, the devices aren't going to be online all the time because, sometimes they're, away from your home, or, they have to be powered down because they're battery powered or something like that, and they're brought up and brought online. So we're going to see a variety of ways these devices are put online. Some of them, are only going to wake up once in a while to transmit their data. And so the answer here is there's a whole bunch of improvements we're seeing there, and that, do your research. I think, again, part of, our Smart Connect or Cybersecurity Month awareness is for consumers to be more aware of, like, if you connect it, protect it thing. And that awareness by the consumer will drive the manufacturers to distinguish themselves. Just the same as, if you're buying a car, you look for the quality of the car and the performance of the car with your consumers, and you get ratings in terms of the quality and performance of the car. We're going to start seeing devices be that way, and from manufacturers. So, but again, there's a life cycle associated with these devices, and some of these devices are going to be in your house, for if they're a thermostat, you might have them for 10 years or 20 years. And so you have to be aware that some of them might become insecure, and you might have to think about, maybe I need to replace them or buy devices originally to have the ability to be upgraded.
Mm-hmm. That's a good point. Yeah. All right, so we have two questions that are connected. Question from the US Embassy Tashkent. Why are some people afraid of 5G? And question from Roshan Sagdiev. What is your point about 5G, good or bad?
Well, again, I was a cellular, I worked for a company that produced, that came out with the first cell phone, so I am familiar with starting with 1G, 2G. Every time that a new generation of cell phones came out, some of these same questions came out. I mean, there was always questions about health concerns with 5G. I think there's been many, many, many studies over the years around that. And, there's really never been any substantiated results that show negative effects in that area. And I think the 5G is kind of in the same boat on that. Again, 5G is kind of in an early phase. So we're starting, there's various ways it can be deployed. And so my point on 5G is that, you have to do your research. You have to find out, if you're deploying 5G infrastructure or you're buying 5G devices, be informed, go out and look at that. What is who's making the device? You have to look at the security of the supply chain. And are those trusted vendors? Are we looking at, and in some cases, do you wait? Maybe you want to wait to buy a 5G device because there might be changes in the architecture and you want to make sure that you're buying something that's going to have some longevity to it. One of the more interesting questions I run into is that, this whole just branding of G, in some cases, people mistake G for, gigahertz. In other words, you buy a Wi-Fi router and it might have a 5G, you might have a 5G router, Wi-Fi router, and that's not the same as 5G cellular. So there's sometimes mixed confusion over the G, where in 5G for cellular, it stands for generation, fifth generation. And there's multiple deployments of this, what frequencies they're being used. I think there's a lot of countries that still haven't decided which frequencies they're going to be putting these devices on. So we're very early on in the 5G. I think, you have to do a lot of research. Again, back to the, concerns, I think from a risk standpoint, the risks are going to be mostly associated with your suppliers and whether they're trusted suppliers and can you trust them in your infrastructure, as well as a consumer. Are you going to be able to trust that the device you're buying is actually getting you the benefit of 5G? I mean, there's a lot of people touting or proclaiming 5G capability, but they're not really, fully associated with the standard, and you will be disappointed. So again, be aware, informed, and get information from trusted sources, because there's a lot of discussion on 5G that is really mostly noise. So you want to make sure that you're getting it from a trusted source.
Mm-hmm. All right, thank you. Next question is from Erkin Eshbaev. Many thanks, Professor. Internet as a public good became a huge factor of globalization. How, throughout its history, US administrations tried to shape it in order to shape a globalized world?
Well, I think, so the internet came about as a result of a United States research effort. It was a Defense Department, actually, to how to get computers connected from research institutions and Defense Department computers, because that's who had the computers during those days. So the internet evolved from a Defense Department, U.S. Defense Department project. So there's that aspect of how U.S. administration started in this whole effort. But during the 1980s, it was they moved it into a commercial space, and the governance of that space, again, it was admittedly very U.S. centric, because that's where the expertise resided. But over the years, the focus of from a technology standpoint has been very much towards how the internet standards are developed and deployed, and the U.S. has a very consistent point of view on that, in terms of that we want to make the internet a multi-stakeholder development process. In other words, we want everybody at the table, that there be standards that are developed that are open, that the governance process is a process that is more of a bottoms-up process than a top-down process. Of course, there's interests that that governments have in the context of the internet in terms of their own security and things like that. But from a pure development internet standards and governance standpoint, it's been very, very consistent over the years that The government the government would play a convening role, like I mentioned the NIST standards. So NIST, even though it's a government agency, isn't really a standards development, but they convene. The governments have a ability to convene these standards organizations and encourage participation from a broad area of stakeholders. And that's really the way you do. That's really you get to the interoperable spot. There's a law on the internet called Metcalfe's Law, which Bob Metcalfe, who actually lives here in Austin part-time now, and he developed Ethernet. But he came out, his law, if you want to call it that, was that the value of a network, any network, goes up exponentially with the number of people that are connected, or the number of things that are connected. And that's what we've seen with the internet, is that this interoperability, this open, relatively inexpensive way to participate on the internet has gotten these 4 billion people online. And those 4 billion people have created this value from not only an information standpoint, but commerce and things like that. So I think, it's I think a very strong effort on the U.S. government part to continue that process. And the minute we start getting into a situation where the internet isn't as operable, it's not as as it could be, then the value proposition decreases, and that's not a direction that any of us need to go. So I think again, we're looking at a interoperable, open, multi-stakeholder, reliable, secure internet, and that's definitely the position we're taking.
Mm-hmm. All right. A question from Jasurbek Talibov. He's asking, can you describe cloud storage on the internet?
Yeah. So once you have all this data, as I was talking about, we've got literally petabytes of data being generated, and as a user, as a consumer, or, even as a commercial organization, it's very, very expensive to provide the technology infrastructure to make that data, secure and reliable and accessible and have high performance and that it can expand. So in the early days, corporations or even people would they'd get an extra disk drive and they'd throw it online or something like that. That became very unmanageable, as I've talked about. Just it's not scalable, and scalable is one of the big things on the internet, as we talked about in my earlier presentation. And so this concept of cloud came up. So in the first phase, it was pretty simple. It was pretty much just a disk array or a set of disks that were available out there on the internet that you could access and store things. So these big cloud providers, and some of them would be like Google, or there's a whole variety of folks that you can Dropbox and things like that. I'm sure every country even has some of its own cloud storage. And so they're just big data centers that are, have very large, reliable internet connections, and people that just do nothing else but make sure that those storage systems work 24/7. And that is and then people subscribe to them, or they pay them fees to put information on that. So what's evolving, though, the important part is, as I was mentioning earlier, is these cloud, storage, they may be hundreds or even thousands of miles away from where you are, either as a mobile user or as from in your house. So we're starting to see new architectures. As I mentioned, if you say, for instance, you're producing data to help manage power on the grid, well, that's more of a real-time situation. Or if you have you have an autonomous vehicle, or even a vehicle that's doing traffic monitoring, it can't really take that extra time to travel that 1,000 miles and come back and get an effective real-time ability. So now we're starting to see architectures of not only storage but applications, particularly artificial intelligence to where it has to be closer to the users. So this architecture of cloud now is breaking down into things like what we're calling edge computing, and where that you're taking your storage and your application and you're moving it closer to the client, or closer to your application. And these are new architectures. They're all part of pretty much the same concept, but they're dealing with new series of concerns in terms of real-time access. And then there's everything in between. I mean, there's edge computing, and there has what was called fog computing, and which is kind of in between edge and cloud. So I mean, there's and these architectures, depending on the application, they might be healthcare applications, they might be mobile transportation applications, they might be various, maybe even stuff that controls your house or security. So it's a combination of technology as well as economic issues that are going to drive these architectures. So cloud was kind of the first idea of just putting a lot of disks out on the internet. Now it's getting much more complicated as the applications and the devices become more broadly across all the different sectors.
Mm-hmm. All right. So we have a question from Bahruddin Gaporov. He's asking, how do you think, how much Zoom conferences are secure and reliable?
Well, they started out, I mean, we kind of almost started out the way that the internet devices started out, as like, the first few came out and they were relatively insecure. I mean, all of a sudden we had people out there that, the COVID crisis comes along, and all of a sudden everybody's Zooming, and there's applications that were just picked up because there was an immediate need. So early on there were issues, but I think as we've evolved just in the past 6 to 9 months, we're seeing much more emphasis on security and reliability, and we're understanding, and not only that, but the consumers are getting they're understanding better of how to set up a Zoom session. I know a lot of educators and schools in our area, they're very much concerned with who's coming onto the session. So we'll still see issues, I'm sure, as time goes on, but it's an evolving situation from both an awareness standpoint and a technology standpoint.
Mm-hmm. Question from Abdurrahman Valijonov. What is your opinion about quantum theory? Is it possible to the existence of such kind of tiny technologies in the nearest future?
Well, quantum's a very interesting technology, and it's very early on in terms of its applications, or even how it can actually be done. There's one of the early concerns in the aspect of quantum computing is, will quantum tend to be able to have break some of our encryption technologies and expose our data, that it's been protected behind cryptography? Will that be a concern moving forward? So there's a lot of, in the context of the internet, concern about how to make our security strong enough that even if, as quantum computing comes online, will not present a risk to that. And how do we take our existing cryptographic information and make that quantum proof, if you will, to develop? Now, quantum computing, and along with it, there's another area of quantum communication. So we're seeing not only developments in quantum computing, but also communication for security. So these are really interesting development. I personally think that in the context of broad adoption of quantum technology, this is a long way away. It's kind of like the supercomputing discussions we had in the 1990s of that supercomputers are going to take over the world, where it's actually distributed computers that took over the world. So I think there's a place for quantum. I think we're going to see a lot of great development in that area. But I think in terms of commercial development or commercial deployment, it's still quite a ways away. But it's certainly I'm not a quantum expert, but I keep track of technology development. That's my opinion on that.
Mm-hmm. Thank you. So comment and question from Dania Hasanova. Wow, water bottle with the internet. Do you have any? Do you know any other appliances that might be connected to the internet?
Well, like I mentioned, I have a lot. So I have I don't have any children left in the house. They all moved out, so I don't have any people to that I can tell to go sweep the floor and everything. So I have robots taking the place of that. So I have 4 robots, 3 sweeping robots and 1 mopping robot, and they're all controlled over the internet. So that's one appliance. I think obviously my air conditioning and heating is all monitored over the internet, and I have that to keeps track of not only the comfort of my system, but also efficiency. So my lawn watering is appliance. So my sprinkler system is controlled to make sure we're looking at water use. So I have a smart meter that keeps track, smart electric meter that keeps track of and I get daily input of how much electricity I'm using. And in some cases that actually can help. Like if I have an appliance or if I have a leak in my water system, say I have a broken pipe or the toilet that's running all the time, I can get a daily review of that information and say, hey, something's going wrong. I need to go look at that. So there's a huge advantage to having that information. So yeah, we're going to see more. I mean, I mentioned the toaster. I mean, literally in TV sets. I mean, that's an appliance. But I think you're looking again. I mentioned it, in 5 years. It wouldn't surprise me that the whole concept of a smart device kind of goes away, because everything that you buy. I mean, if you buy a TV set right now, I mean, there are no TV sets without internet connections anymore. I mean, literally every TV set you buy is going to have one. So calling it a smart TV is kind of like redundant. It's kind of like buying a transistorized iPhone. It's redundant. So I think we're seeing that. So it wouldn't surprise me that vendors are going to use internet connections and data and control systems to sell their devices. So 5 years from now, when you buy an appliance, it will likely have an internet connection, whether it's a toaster or anything else. So I've seen internet connected toasters that use artificial intelligence to determine how you like your bagels toasted. So that's where we're going. Computing is cheap. Networking is cheap to put in. I mean, we're talking about literally in U.S. terms, like a dollar or something like that to put that into a connection, and it provides a lot of value to the consumer, or at least perceived value. And so we're seeing a lot more of that. So like I said, my son is buying a house that has almost entirely controlled. They're calling it in some of the neighborhoods Amazon houses, because they have Alexa capability for controlling everything in the house: your lighting, your heating, your entertainment, your security. Everything's controlled through voice commands. So yeah, a lot. There's going to be a lot. So I would. The answer to your question is, in 5 years, you're going to have a hard time finding an appliance that isn't internet connected.
Thank you. Comment from Isato Samarova. Thanks a lot for the fabulous presentation. And a question from Mavlon Babahon. Thank you for such a kind of interesting presentation. What do you think about the idea of some countries separating internet from their citizens and organizations?
Well, I'll go back to my comment about Metcalfe's law. I think the value of a network and connecting to a network goes up exponentially with the number of people connected to it. So I think any effort to break that value chain. In other words, decrease the value by not having people connected. That's a very, very, I would be concerned so that of any institution or any change to the connection to the network that would decrease the value to the citizens. So I think, I think most people would recognize that being connected to a broad space of the world has more value than not being connected. I think that's what has gotten us to the 4 billion people. And that's been an adoption that hasn't been forced by anybody. That's just people adopting the internet on their own, and they want to be connected to a large set. And I think from a security standpoint, we're starting to, and that's an evolving situation. So we're going to see new security that, at the data level as opposed to the network level. I think most people are saying, well, I don't want my data to go across the border. Well, and so I'm going to cut off the network. Well, there's other ways of solving that problem other than cutting your network connection. You can make your data more secure, more contextual to its location and to its use, and that you can do it in ways that don't involve cutting the wires for the network. So that, I think we're going to see that evolve and maintain the value of those connections and still maintain the security as well.
Mm-hmm. All right. We have a question from Erkin Eshbayev. How can we embed European values into global cyberspace governance? What are the challenges? Is U.S. government one of the challenges? As some countries doesn't trust Washington, which exercises its power.
Yeah, well, I think that's just part of the same conversation I was having. I think what we're seeing, as the maturity of the internet evolves, we're seeing the ability to contextualize our information and our data in ways that allow you to have different privacy rules and different rules concerning how security is done, and still maintain the interoperability of the internet. So I think solving this situation is that you look at the standards, and whether they're data standards or whether they're networking standards, and you look at them and say, how can I contextualize within my country to be able to comply with the concerns that we have within our country and still maintain the connections to the internet. So I think looking at that layered model as I started, the layered architecture of the internet, is that if you have a problem that involves some area of governance, solve it at a higher level of the stack rather than a lower level of the stack, and that will maintain the value of the connections to the internet. So I think there's a solution out there, and I think as we bring another important message here is, for many years, the technology community and the policy community have not communicated very well. So I encourage everyone to find a way to have these two communities to come closer together. The reason I'm at the State Department as a lifelong engineer and technologist in the private sector was it was my awareness that I had to contribute to this process of bringing these communities together and having them understand, where the technology is going, as well as in the other direction, the engineers understanding the policy concerns, so that they can develop things that are more universally interoperable and can evolve as the needs of the community evolves.
Mm-hmm. All right, thank you. So we have a question from Yevgeny Merkulov. I know we already discussed 5G, but if you could just summarize what we talked about. He asks, could you please explain why it concerns about 5G network? Is it safe for people?
Well, again, I go back to the other discussions. I thought, cellular networks, there's always been concerns in that area. There's been lots of studies, health studies done. So from that standpoint, from the pure standpoint of radiation of that, I think there's been quite a few research areas, and to my knowledge, there's never been any proven connection with that. I mean, we've even had people, be concerned about smart meters and Wi-Fi and a lot of these other wireless technologies that we've had in our lives for many years. And so I think 5G is just an evolution of those things. And so I think there'll be plenty of data out there to suggest that there's not a health concern. Now, safe for people, there's a lot of, safe is a word that could have a lot of contexts. So I think the safety there's safety from the radiation part, there's safety from the data part, there's safety from, being able to be exposed from a privacy standpoint. And I think, where these architectures are evolving, I think that we're going to see, as we're still seeing, 5G deployments are early, and these concerns are being raised early enough that I think both the governments and the consumers and the vendors of these networks are now fully aware of the concerns of the people out there. And in order to get, the idea is how these get adopted and for people to use them. And so these concerns are going to have to be addressed, and they are being addressed, I believe, for deployment. But they're not new concerns. So I think if you go back to any of the generations of cellular networks, you're going to see a similar step. But because there's more devices, there's larger concerns. And so, but again, the consumers are in the power position here. They're going to have to adopt it. They're going to be the ones that put their money out for a 5G device. So there's going to have to be addressed. I assume the marketplace will force those concerns to be addressed.
Mm-hmm. All right. Thanks so much. Len, I don't see any questions so far, and actually we're running out of time. We're 10 minutes late. There were so many questions, and I want to thank you for taking all of those questions and answer them, and make some questions that probably even I thought about. You made it clear for us, and I hope your presentation will make everyone think about how secure they are online. This is a great time for your presentation during the Cybersecurity Awareness Month.
Well, thank you very much for the opportunity. And I've traveled, millions of miles in my life, and I've still not been to Uzbekistan. So I hope now that if I come there, somebody will, show me around and introduce me to some great food, which I've seen, on the internet. I'm a big fan of eating the local food stuff. So I look forward to a visit there when we fly again.
Definitely. You now have friends in the face of American spaces in Uzbekistan and US Embassy, and of course that many people who saw you today. So we'll be happy to see you in Uzbekistan whenever this COVID situation becomes normal again.
Great.
Please. And I also want to thank the Office of American Spaces, who gave us this wonderful opportunity to meet Len Hause today and have him interact with audience in Uzbekistan. And I want to thank everyone for wonderful questions and remind you that we're gonna meet next Friday, and we'll have a Deputy Chief of Mission, Ellen Meltzer, talking about US elections. So don't miss that chat to next Friday. All right, Len, thanks so much, and have a wonderful.
Thank you.
I hope to see you in Uzbekistan.
And we'll see you again soon. Take care.
Bye. Take care.
Be safe.
You too.